Hello and welcome to Advent of Code in F#, day 2. I got my fresh pot of coffee brewed, so let's start. Or maybe before we start, I want to go back to day 1. Because I saw some code from my colleagues who are doing it in C#, like the new syntax with record types. And their solution was really interesting. Or their solution for building like all the combinations from yesterday was really interesting because it's like this really elegant link statement from select boom, and I thought, whoa, that's a crazy lot more elegant than my recursive and mutually recursive functions. So I went back to my F# implementation, which used like these things: pattern matching on lists, calling other functions recursively, mapping, crazy. So I just used 4 comprehensions as well, and it's a lot more elegant. So yeah, just wanted to share that. With that being said, let's go to Advent of Code, day 2. Password philosophy. Passwords again. Oh no. Our flight departs in a few days from the coastal airport. The easiest way down to the coast from here is via toboggan. Toboggan, what is that? Kind of a boat? There's a simple sled. Oh, that's something else entirely. Cool, so we're going sleighing. The shopkeeper at the North Pole toboggan rental shop is having a bad day. Something is wrong with our computers. We cannot log in. You ask if you can take a look. Of course, their password database seems to be corrupted. Some of the passwords wouldn't have been allowed by the official toboggan corporate policy that was in effect. I hate password policies at these big enterprises. Okay, so we have passwords, we have policies, cool. To try to debug the problem, they have created a list, which is our puzzle input of passwords according to the database. So we have the database of passwords, plain text, really? I'm kidding. And the corporate policy when the password was set. Okay, so we also have the policy. Suppose you have the following list. Yeah. Each line gives the password policy and then the password. Okay. Policy indicates the lowest and the highest number of times a given letter must appear for the password to be valid. Okay, cool. So 13A means password must contain at least 1 A and at most 3 A's. Okay, that's clear. 2 passwords are valid in the example above. Yeah, this one has an A. This one does not have 1 to 3 P's, and this one has 1, 2, 3. Yeah, that's enough 9s. So our password input, let's just quickly, okay, that's a big list. And let's take a look at the kinds of inputs. So it's always numbers, or a range of 2 numbers and a letter, and then the password. Numbers can be pretty high, so it's not just single digits. Okay, let's put this in a file somewhere. So there we go. That's day 1, I'm sorry. Let's roll that back and let's open day 2. That's better. So, and let's quickly read it out. Come on, REPL, you can do this. Okay, so yeah, we have our password database, and now we can start working. How would we solve this? Whenever I see these lines with information, with structured information, I think parsers, but for this example, writing a parser using like a parser library is maybe a bit of overkill. So next best thing is maybe regular expressions. I'm really bad at them, so disclaimer. But let's go with regular expressions. Whenever I have to work with these regular expression things, I need help. So let's find an online regular expression, or regex online, whatever. There's a good one called regex, or there we go. It's like an interactive, it's a REPL for regexes. I need this. whenever I'm working with regexes. So say we have something like this, how do we parse out the policy and the password then? So start to end, and dollar is the end. What's the beginning? Caret, like the little hat thing. I'm using a new keyboard, so I have to look that up as well. Yeah, beginning end, and then we need a number of digits, I'm guessing. I'm gonna print it one off so we can see what we're matching. So beginning of the string, and then some digits, and then minus, yeah, and then some more digits, yeah, and then a space. What is that? W? Is W's word? It's everything except the words. S, white space, good enough. Then it's the letter, so that's a character. What's that? Is that a, yeah, W works. Then okay, another space. No. Why is it not working? Matches a character, yeah, word matches any word character. It stopped matching after I it's white space, it's not a character. Whoa, it's early, sorry. And then we have the password, which is a lot of word letters. There we go. So this matches. Maybe to be sure, let's put an end marker on it. So this is a regular expression that matches everything, but we need to parse it or extract the content. For that I like to use what's it called? Groups. And now I'm gonna have to look up the syntax and why I'm doing it, maybe a step ahead. In F# you have this thing called a type provider, and type providers are a construct that provide on the fly dynamically generated types. So it's a bit the best of both worlds. You can do like dynamic stuff like read in JSON or have a regular expression in this example and give it to something called the type provider, and it will generate a type for you, so you can work in a typed way with the underlying data. I'm not really explaining it well, so let's just look for the example. Regex provider F#. Yep, that's the one. So this will work better. So this is the regular expressions as we all know and love them, but the new magic is this thing, and what this thing does is it generates a type for you on the fly that you can use in your code. So for example, if we have this phone number regular expression and we give it to a type provider and we use this generated type, we can do like stuff like .area code, where area code is one of the groups in the regular expression. And if you mistype area code somewhere in your code, you will get compile errors because this type provider generates the type information from that regular expression. So that's, for me, I dislike working with regexes, but this makes it a bit more fun. So let's pull in this library. It's a NuGet package called F# text regex provider. Cool. Yeah. So let's require that. NuGet. There we go. Let's load it in. It's saying, why are there red squigglies? Okay, because I haven't gotten the library on my system yet. There we go. Open F# text regex provider. Maybe. What's it saying? Yeah, and then it's just syntaxes. Do this and then make new this. Just gonna copy paste it. Let's not overthink it. So there we go. You define your regex type by giving it a regular expression, and then you can use it. Okay, cool. So why am I making this segue to this library? Because of this. If I give my matching groups a name, like area code and phone number, I can work in a typed way in the rest of my code. So what's the syntax again? you have this question mark and then these tubes and then the name of the group, and you surround the name and the matching pattern in brackets. Okay, let's pull these side to side because I'm not going to be able to remember this. Come on, yeah, there we go. So what do we need? We need the policy, which is these two numbers. So let's get the first number first. This, no, come on keyboard. Yeah, min, let's call this min. And it's this part. Let's see if we can see the match. Yeah, that works. Max is this part. Min max 817, that's so correct. And then we have a white space, and then we have a character. Yeah, let's just call it character. Min max character, yeah. And then we need the password, which is the characters at the end. Password. Oh no, error. What's it saying? Do I need to capture the entire string? No. What am I doing? Okay, I mistyped. This needs to be a. There we go. So I think this still matches the string, yeah. Min, max, char, and password. That looks correct. Let's fully name this. So I think this is my regex. No, I think this is my regex. Let's pull it into the code. Yeah. So bam, there we go. Let's call this password regex. Why not? It's a password and your policy, but remember that. Okay, let's just, for the fun of it, take one of the examples with a multi-digit password policy. There we go. And let's just put it in here. Area code doesn't exist, that's true. So, I'm sorry, I need to load in the regex type. I need to load in everything. There we go. And we have a match. Let's see if we can extract things like a password. Dot value. Okay, that looks good. And like to show you the type provider, if I typed Pizzazz, my compiler is going to say, well, red squigglies, this is not a group in your regex. So that's a nice to have feature. Okay, so now we can parse our lines. Let's go ahead and parse them. So the input contains the entire database. So let's loop over the input and let's map it, and we map it using this. Yeah, we map it using this. I think it's complaining because we need parentheses. So then it's parsed in this regular expression, but do we need to go further? Yeah, let's extract what we just parsed into a custom type. That's a bit more fluent to work with. So what kind of type do we need? We have a policy and a password, but let's just keep everything in list in a one data structure called password. Yeah, why not? Min is a number, max is a number as well. The character is a, what's it called, char, yeah. And then the password itself is a string. So this is the type we want to parse our stuff in. And now we need to go from a regex to this type. Let's call m the match we have, and then return our new type. where min is match min dot value. Is it value? It's not this, it's this. Yeah, there we go. So min, okay, max is our max value. Character is our character value, and our password is password value. So there we go. Oh yeah, and then we need to parse everything's a string in our regex. We need to parse it. So our min should be an int. Let's just parse the min string to an int. Max same. Character parsed as a string. Do we care? Yeah, we care. Can I do this? Let's see. Let's go over the first one. Let's print out the first parse to see if it's working correctly. So the first parsed password is 5 to 6 of an S, and that's this password string. Is that the first? Yes, we have 5 to string of an S, and that's a string. Yeah, that looks good. So now we have all the parsed passwords. Let's call this parsed. And let's make it a to list. Let's make it a list so it evaluates. We need no lazy loading here. Okay, there we go. We parsed our password database. Next step. Where were we? This, yep, there we go. That's our input. So now we need to find the passwords that are valid according to their policies. So we need to go over every parsed password and see if the policy applies. Cool. So I'm gonna look for the valids, and the valid passwords are the ones that we parsed. And let's filter out. What's the domain language here? How many passwords are valid according to their policies? Let's call it is valid. Let's write a function is valid. Is valid and a password of type password, and that should return a bool. So okay, how do we implement this predicate? We have a policy that's saying you need this character this many times. So we need to count the number of characters. How many times the character occurs in the password itself. So we have password dot password. So this is the password string. And we need to find the number of characters. How do we do that? Count, filter, where? So what's this? A string? It's a string. What's the easiest way to count the number of occurrences in a string? String is a sequence of characters. We can just do it that way. Yeah, let's do it that way. Count by a key. Is that what we need? So we have a sequence of passwords. No. Let's just filter. Yeah, let's just filter. And the character in the string must be what the policy tells us the character should be. and then we just count these up. Length, there we go. Occurrences. How do you write occurrences? Is this how do you write occurrences? Not sure. So then we know how many times this number is in there, and it should be between what the policy is saying. So return password dot min. So it should be between this and the max. Return is not something you want to use in this context. So I think this might be... Let's give it a try, and if it doesn't work, we'll test it. Sometimes the best test is just running it, or the fastest test. Let's see how many valid passwords we have. $638. Okay, so no testing needed. We're good. Part 2. Let's have a sip of coffee first. And before I rip up the code, let's copy paste it. That's my strategy. Don't try to maintain backward compatibility for these puzzles. Just copy paste the file and start hacking away at part 2. Okay, what do we need to do in part 2? It appears we validated the passwords correctly, but they don't seem to be what the official authentication system is expecting. Great. The shopkeeper suddenly realizes that he just accidentally explained the password policy rules from his old job at the sled rental place. Great. So the toboggan policy works a little differently. Each policy describes 2 positions in the passwords, where 1 means the first character. Okay, so it's also 1 instead of 0 as first character. Great. So it's not a min and a max, it's a position of the character. No index 0, yeah, I see this going wrong for me as well. Exactly one of these positions must contain the given letter. Okay, so it's 2 positions. In one of these positions we need to see this letter. Exactly one of these positions must contain this letter. Our occurrences of the letters are irrelevant for the purposes of policy enforcement. Irrelevant. Okay, so we only need to look at those 2 indexes and see that one and only one of these indexes has the character in the policy. So basically, whatever we have right now is correct, only the is valid check needs to change. Before we do that, it means that it's not just min and max, it's like 2 positions. So let's call it position 1 and position 2 instead. I'm also going to change the regex for consistency. Let's clean our REPL so we don't have anything remainder from last run. Do we still run? We still run. It should be pause 1. This should also be pause 1. Why is it still why is there no red squiggly under my regex provider? Max shouldn't exist anymore, right? No, it should be pause 2. Okay, there we go. It was hidden behind another compiler. Okay, so this is all still correct. Okay, now we don't need to count, but we need to find the 2 characters at these positions. That's actually easier than what we had to do before. So at 1 we have password at the index of position 1, and it's 1 based, not 0 based. So that means when we have 1, we have to subtract 1 and add 2 is 2, and 1 and only one of those two has to be the character in the policy. I'm thinking of clever ways of doing it. I'm failing of coming up with clever ways of doing it, so let's just do this. If it is password.character. Is there like an exclusive and, exclusive or thing? It's gonna be something like that, but I'm not awake enough to look up stuff like that. So it should be that 1 is the character and 2 is not the character. Or the other way around. Yeah, that sounds like an exclusive and or whatever. That sounds very much like one of those. But okay, let's get it working first. Or 2 should be the character and 1 should not be it. I think this is it. So let's reread what we did here. Find the character at the first position. Offset 1, yeah. Find the character at the second position, yep. And then just check that only one of the two matches. Yeah, I think that's the way to go. So let's see how many valid passwords we have. 699. It's eerily similar to the first part. Okay, and that's correct. So there we go. Day 2 in F# without a single test. But we have a solution. Thanks, and see you tomorrow.